All right. Thank you for the opportunity. I'm going to talk about software. Okay, right. Software composition analysis with precise vulnerability identification for critical software risk assessment. So we have talked about this for quite a while. I mean, the root cause of the problem is lack of the transparency in software, right? So there's already some statistics about how much it costs to fix a vulnerability like Log4j. These are some more numbers. As you can see, the average cost for fixing these Log4j vulnerability is about $90,000. And one federal cabinet department has reported that it spent like more than 30,000 hours to this Log4j vulnerability response alone. So when you are involved in this kind of situation, you're like, wondering, can I have a tool that can tell me what components are there in my software? Does this software indeed has this vulnerability, right? If I have this tool, that would be great. I would like to have it. So this is exactly what Deepbits tries to provide. So our Deepbits platform can take whatever application you have, source code or not, binary, okay. So with this software you provide to us, we'll provide accurate SBOM information, right? You can translate SBOM from different formats and back and forth. Thanks for the protobomb project, we're also part of it. So we can, in addition to that, we also provide precise vulnerability identification, which means I can tell you exactly in your code where their vulnerability is. So with that information, we can help to produce more secure application to help developer teams. We can help the customers to pick better software, right? Suppose you have multiple offers, which one do you pick? It can also help the operation team to operate your software assets to have a clear view about the security threats in your organization. All right, so just a little bit more information, details about how we operate, how we build our solution. Of course, we're using AI. We're using other solutions like program analysis, binary reverse engineering, but one of the key features is the AI, okay? We take your binary application and we use our deep neural network to convert into high-level representations and then compare that representations with our knowledge base, which means we have a bunch of open source libraries in our knowledge base. We compare this to our software with our knowledge base to identify its components. We also have a very fast and accurate graph matching algorithm. So in addition to the individual features, we actually match at the graph level to give you more accurate and precise SBOM information. So like I said, our solution can work for source code and binary. And you can also build your own library database by simply upload that library binary to our system. In addition to that, we also provide SaaSBOM, which means if application use any SaaS service endpoint, we can identify them and tell you which SaaS service you are using, like Auth0, okay? So, and then we'll give you this report and the visualization that you'd like to have. So in addition to identify these components in your software, we also provide this precise vulnerability detection using this fast graph matching and diffing algorithm. So for example, we can detect there are 13 vulnerabilities in the popular Zoom conference, video conference software. So just some quick demo. Can I play this? Okay. Right, so you can see you can upload your software assets, any formats. And then we can also link your AWS account so that you can scan your cloud assets. And then you can view this information, visualize it. And if you want, you can also further export the information as a report. So for example, in Zoom, we identify this OpenSSL library, which actually is a vulnerable version, right? So this provides some more information about CVEs might have, and then we provide precise identification and identify which function actually is vulnerable in your software. So with that, thank you.
So thank you for the presentation. One common criticism of SBOM is that it talks about the component but not the function level.
Right.
So is this something that your tool can actually do automatically through the binary analysis? Is say you are using this component, but you can sort of prove the negative that the affected function in a vulnerability is not in, and then you can sort of say, this is not vulnerable?
Yeah, so this is exactly what we're talking about, right? So in addition to tell you that you have these components which might be vulnerable, according to the version, according to the CVE database, you may have 10 vulnerabilities, but we are further confirming the presence. Maybe in reality, you only have one vulnerability in your code. The other 9 are actually not included in your software. So that's what we can tell you.
So you can attest to a lack of risk?
I mean, attest may be too strong a word, because the graph matching is an NP hard problem. We try our best, so there's a slight chance that we may miss it, right? Yeah.
Okay, so you talked about leveraging AI capability to do this, right?
Yeah.
Okay, how often do you have to train your model to kind of understand the composition of those algorithms or those softwares?
So we fine-tune a large language model to perform this task more accurately, but that fine-tune is very infrequent event. What's more, what's more time-consuming is actually the accumulating our knowledge base, which means we collect these different packages and put that into our knowledge base. But that's a one-time effort.
Just so I understand kind of how the matching works, it sounds like what you're saying is, you read the code, create a graph, match that graph against the existing one that you have in the system, and you link entities, components of the software, and then match that against vulnerabilities that exist in the wild. Is that accurate in terms of how to think about it?
Very accurate.
And then I'd love to understand kind of how you all are staying on top of the known knowns in the vulnerability world, and how you keep essentially the data that you're using to train the model fresh.
Yeah. So there are two points, I guess. One is that how do we keep up with the vulnerability information, right? So there are so many. So we focus on the critical ones, or the ones that we can actually know their precise location in your code. There are actually plenty of CVEs that don't give you that location information. So like I said, we focus on the critical ones that have known location, and also the ones that have known exploits and POCs. So that set is much smaller, right? The other information, how do we keep up with the application, the packages out there, right? So we actually have different tiers. First of all, for the large majority of these packages, we first extract the simple features, like strings or other simple patterns. And in addition, on top of that, for the most popular one, most critical ones, we will further process the code. So otherwise, it will be too much resource we need to consume, right?
So seems like really cool tech under the hood. Can you talk to us about what the customer experience is like? What's the usability part? How does this integrate into a dev environment?
Right. So the integration is actually very simple. We provide the REST API, and full documentation and example scripts are there. So it's actually very easy for the customers to integrate into their workflow because they just need to call our API, whether it's a CI/CD workflow, whatever the way they want to integrate. So actually, there are some interesting stories in terms of, okay, we found these CVEs in your software, and we actually tell them, hey, this is the location we found in your code. And first reaction, wow, you found it. How can you find it? Show me. And then they arrange a meeting with us immediately to talk about this and then talk about what they should do next step. Yeah. All right.
Thank you very much.
Yeah. Okay.